further illustrate the point about correlations, I want you to look at this correlation. This shows the correlation between the global average temperature of the Earth in degrees Celsius and the number of pirates in the world. And this is going back obviously a long time. So for example, in 1820 there's an estimated 35,000 pirates in the world. And the average global temperature was about 4.2 degrees. And over time, we've had less and less pirates. But at the same time, the average global temperature seems to be going up. Now, the assumption that most people would make about the correlations would be that if the relationship or the correlation between these two things is if the number of pirates goes down, the average global temperature to go up, that the way to fix global warming is to have more pirates. Obviously, having more pirates is not going to change the average global temperature in the world. If it's that simple, we just introduce more pirates, and if you believe in global warming, now I'm not going to get into that, but anyways, you would assume that you could fix global warming by having more pirates. Obviously, that's not the way correlations work. There's some other set of data that is the true relationship here that we're completely missing out on. To give you another example, how about these? There's a positive correlation between ice cream consumption and drownings. There's a positive correlation between ice cream consumption and murder. There's a positive correlation between ice cream consumption and boating accidents. And there's a positive correlation between ice cream consumption and shark attacks. So on the surface, it appears that ice cream seems to be really bad for people because people are drowning and getting murdered, having boating accidents, being attacked by sharks. What we're not accounting for is one other variable. Well, the variable is warm weather. When the weather is warm, there's more people swimming. When the weather is warm, there's more people out on the boats. When the weather is warm, there's more people swimming, and there's more shark attacks because there's more people swimming. And in fact, when the weather's warm, people eat more ice cream. So the correlation between each of these things, each of these points, is not the ice cream in this event, the secondary event. It's something else. It's warm weather. That is the difference between the correlation and cause and effect. Very often we miss the cause and effect because it's something else. Now, when I read this several years ago, this is the one I can't quite figure out. I guess when the weather's nice outside, it just makes it easier to go out and kill people. I'm not exactly sure how that comes about. Or maybe when it's cold, you just stay inside. You don't worry about it. That's kind of a strange one. So it would be crazy to assume that we could solve drowning, boating accidents, shark attacks, and murder just by banning ice cream. That's not what it is. That's the difference, once again, between correlation and cause and effect. And that is why this R squared is valuable. It is the explained variance, because if we can figure out how much we're missing, it'll tell us to go look for something else. Now, to show you a few examples of correlations, this is a assignment paper from chapter 3. Let me blow this up a little bit bigger. When you actually see the correlation coefficients, and these are Pearson's, what you'll end up seeing is a chart like this. And the first thing you'll notice on most of these examples is half the chart is gone. The reason why is because, for example, we have this correlation between inventory to diagnosed depression and the Hamilton rating scale for depression. Well, the correlation between here and here is exactly the same. Sorry about that. Exactly the same thing as the correlation between this and this. They're just inverse. So very often you'll see half this stuff gone. Correlation between IDD and IDD, well, there's not one. It's the same thing. So that's one of the things. The first number you'll notice is this correlation coefficient. It's 0.57. It's 0.41. 0.39. Numbers like that. That tells you how strong the correlation is. The next thing you'll see is these asterisks. And that tells you how significant the correlation is. And if you'll remember from a previous video, it's this 0.05 is our magic number. Anything that's where the number is less than 0.05 is a significant correlation, and we can safely say that there is something to that relationship. So, for example, even though there's a correlation here, it's not a significant correlation. The correlation here is not as significant as the correlation here. This one is 1 chance out of 100. And I know that you don't really may not really understand this 0.01, 0.001, etc. That's okay. That's going to come later. That's a different lecture. These relationships between this GAF and all these others on the left-hand side, well, there is correlations. They're negative correlations. They're just not significant. Now, here's the other thing about these correlations. Significance is like pregnancy. You cannot be almost significant. You cannot be almost pregnant. Either you are or you are not. Either you are significant or you're not significant. There's no almost in this. Now, just like pregnancy, you can have degrees of significance. You can be more pregnant than someone else. You can be 9 months pregnant as opposed to being 1 month pregnant. But pregnant is pregnant, significant is significant. And what this means, this 0.001, is we just have much, much more confidence in the relationship between these two numbers. So that just gives you some examples of what these actually look like. And most of these will show up in tables. The other thing I want you to notice is it also describes the relationship up here. And although it gives you the correlation coefficient and the level of significance, here it's defining it, the true significance. It gives you the exact number. Down here, it's just giving you a range. So this BDI is 0.39. It has 2 asterisks. Well, 0.009 is less than 0.01. And the reason why we do this sometimes is the software programs that produce these numbers will only go to 3 decimal places. So if this was 0.0094665, well, we don't want to put that in there. So that's why it'll have something like this, which is okay. Now, that pretty much covers the correlations. Now, the end of this is that you have an assignment to do for chapters 2 and 3. I'll send that out as an assignment. The readings are from the folder called assignments, or excuse me, articles for assignments. There's articles for chapter 2. There's articles for chapter 3. Some of them are kind of long. I wouldn't print them out unless you just absolutely have to. So you'll need to do that. I'll send the assignment out through WebCT, and you need to turn it back into WebCT, and it'll have a due date for that. Thank you. That's it.